It's been over 2 years since I started working on the Igbo API, and it's grown significantly. It holds thousands of edited, audio-supported multi-dialectical word entries and example sentence entries. To search all this content accurately took a really long time to get right, but to be honest, it's still not technically perfect. Over a year ago, I made a video walking through the approach that we use to search for documents in the database. That approach involved creating a regular expression that's used to match for expected word entries. Since that video, our approach has changed significantly. This video is going to go over the current state of search for the Igbo API and explain the reasoning behind why it's the way that it is today. So the current way that the Igbo API searches for words is in 4 steps. 1, we create 2 types of regular expressions. First is the word regular expression that will be used to search for headwords or other Igbo content within a document, and then definition regular expression that will be used to search for definitions or English content in a document. From there, using both regular expressions, a MongoDB word search query is generated. The generated query will be passed into an aggregation pipeline to ultimately return the matching word entries, and then finally we sort those matched documents to present the most relevant document to the user first. So most relevant is going to be at the top of the array, and the least relevant is going to be at the bottom of the array. For this video, we're going to be focusing on the first 2 steps of this pipeline, generating the regular expression and the MongoDB queries. So I want to answer the question of why 2 regular expressions. So why did we go from 1 regular expression to 2? So as mentioned before, we generate 2 types of regular expressions, the word regular expression and definition regular expression. You can find these regular expressions in our create regular expression file. And right here you can see that we have word reg and definitions reg. I decided to generate these 2 types of regular expressions so we have more flexibility on how we want to pattern match with the content found in the database. Later in this video, hopefully that concept kind of becomes more clear. But for now, let's dive into why these regular expressions look so ridiculous. So we're going to start off with start word boundary and end word boundary. We want to match with whole portions of words. In Igbo, a word can be made up of multiple parts. For example, this word means to run, and you can see that there are 2 distinct visual blocks that make this word. So if we want to be able to match to this word, then we allow our user to be able to search using GBA space, OSO, maybe even GBA, or even just OSO. But we don't allow our user to type in something like BA space OS and then get that word matched. In that case, nothing would be returned because it's not matching to a whole portion of the word. So the start word boundary and the end word boundary prepend and append word boundaries so that the regular expression will match with whole word parts rather than sequences of letters found in a word. The start word boundary looks like this, and then the end word boundary looks like this as well. Next, we have front and back. The front and back are used to strictly match with the provided search term as a whole. So notice how there's a hard match boolean that determines which regular expression is used. If the hard match value is true, then we use both front and back to make a more quote-unquote strict regular expression that will match more directly with the Word document's content. So again, with the example of this word, we would need to type in GBA space OSO in order for us to get the expected Word document to match. But if we attempt to type GBA or just OSO, then we wouldn't match with the Word document because it's not matching with the entire word. By default, all requests use a not hard match or a soft match, so more entries will be returned to the user. The reason for this design decision is because we're assuming that most users will be searching for terms in English or Igbo with a few typos, so we want to make the API as flexible as possible. But developers using the Igbo API have a lot more flexibility. They can pass in a strict parameter in the request to enable the hard match boolean. Next, I want to talk about NFD and NFC. For the most amount of flexibility that we get from these regular expressions, we actually want to pattern match with the search term that's provided from the client when its characters are normalized with both NFD and NFC normalization strategies. So let's quickly talk about what these strategies actually are. NFD, or canonical decomposition, is a string normalization strategy that will separate all Unicode characters from each other, including diacritics and underdots. So again, let's look at this word as an example. At first glance, maybe you would assume that the length of the string would be 7 because you have GBA space OSO. But in reality, the length of the string is actually 12 because we split up all these visual markers. So we end up having 12 characters because of our letters, GBA, OSO, our space, and then our diacritic marks, the macrons above the A and the O's, and then our underdots beneath the O. NFC, or canonical composition, is the opposite to NFD, and it's a string normalization strategy that will combine all Unicode characters together as much as possible. So if there's a diacritic mark or even an underdot that can be applied to a preceding character, then they'll be combined into one letter. So when we look at this word example again, the length of this string will actually be 9 because the first A in the string is combined with the macron diacritic mark above it. Then the two O's are combined with the underdots right next to it, leaving the two macrons to stand on their own. And it's fair to wonder why we wouldn't actually combine the macrons into the O's with underdots. The reason why they're not completely just combined into one character by themselves, equating the entire string to have a length of 7, is because that there's no unique Unicode character that represents the letter O with an underdot and a macron all in one. So if you attempt to check to see if this word is equal to itself, where one side is normalized with NFD and the other side is normalized with NFC, you'll get a falsy value. Even though they visually look the same, they are composed with a unique set of Unicode values. This is important to note since even though our words in our database are normalized using NFD, consumers or clients might be passing along characters that can be normalized using NFC. So we want to handle both cases, hence the two regular expressions being placed next to each other with the pipe symbol. The way we generate these NFD and NFC regular expressions is by going through each letter in the search term and then looking it up in what we call a diacritic codes object, which will convert that letter into its corresponding Unicode value. The diacritic codes object contains all alternative special characters for the provided letter that are commonly used in Igbo. So for example, if the provided letter in our search term is I, we look up the letter I in our diacritic codes object, which will return an array of Unicode values that represent the regular I with an acute, grave, and macron accent, and then the regular I with an underdot, and then that regular I with an underdot with an acute, grave, and macron accent mark. If there's no match in the diacritic codes object, this just means that we're dealing with a regular letter that doesn't have an alternative or similar character in Igbo, or isn't even tone marked. So for example, a letter like this would be G, since there's no alternative G with an underdot or even a G with a tone mark applied to it. Once we get either our series of Unicode values from diacritics codes or just a singular letter, we normalize it by using NFC or NFD. There are a couple extra things that I want to call out while we're generating regular expressions. Letter duplication. In the case where the last letter in the search term is the same as the letter that came right before it, we use the following regular expression pattern to handle multiple or duplicate letters at the end of the search term. Plural and Gerund. So we also want to handle the case where a user types in maybe something that's plural, like the word kings. We want to match with the Word document that has the singular word king in it. Similar cases to this are words that end with es or ing. With that, we've generated our regular expression for our word reg. But what about our definitions reg? It's actually very similar to word reg, except that it doesn't use front and back because we want the pattern matching to be more loose, and we assume the grand majority of our users will be searching in English. I also want to address a popular question: why not use text index? We were using MongoDB text indexes before, but we found that they were quite limiting in their ability to match expected Word documents. And this was a really serious problem because it would essentially hide a lot of the data that we were telling people that we had in our database. MongoDB does support the Igbo language through their collation aggregation step, and we were using it to specify the language, whether we wanted to normalize queries, and even strengthen the text index. I actually went down a rabbit hole of using collation, but I realized it just wasn't doing the job correctly, and it wasn't able to find the documents that I was expecting to find. Many of these matching problems came down to the fact that we had to support diacritic marks and a foreign language, in addition to handling text that can be normalized with different strategies. Text index didn't handle these cases that well. But with all that said, I'm actually open to hear what others think about this problem, since I haven't been able to find much documentation, articles, or research on this particular situation of Igbo or other non-English languages and how to query documents efficiently. Now that we've generated our regular expression, it's time to start generating the queries used to match with the Word documents. I created my own concept of a full text search by creating the following function, full text search query, that generates a MongoDB search query. This function can be found inside of our queries file, and it kind of looks intense at first glance, but we're really going to be focusing on the last object in the ternary operation that starts with $or. Essentially, we're using a combination of the search term provided by the client, the generated word reg, and then the generated definitions reg. We use word reg for the head word and the regular search term for the head word, spelling variations, incivity, dialectical variations, and even verb tenses. The The reason why we're using the keyword and the word regular expression for the word field is because we want to support a multitude of different cases that might happen when someone searches for an Igbo word. For context, all of our Igbo words are tone marked properly, but I wouldn't be surprised that a lot of our users don't add tone marks to their search queries. So in the case if we just use keyword, we wouldn't match with many of our documents if we were searching without tone marks. We don't want to place the burden on our users to place tone marks on their search queries in order to actually get our word data. Rather, we put that responsibility on our system by generating the word regular expression that can handle checking to see if a word has diacritic marks or not, and then loosely matching based off of the user input. But keyword is used in other fields, for example in Cibity, which actually takes Chinese Unicode. So we wouldn't want to generate a word regular expression or just a regular expression in that case. Rather, we just want to make sure that if someone is going the distance of inputting a Chinese Unicode to match with our document, we want to make sure that we're pulling up the correct document in that case. For the definitions regular expression, we use it within our definitions strictly. Definitions is the only part of our Word document at the moment that has English content. The benefits of creating word reg and definitions reg shines brightest in this case when we're constructing our search queries, since we have more freedom to decide which fields we want to place our regular expressions in. But with text index, we had to trust that MongoDB performed the most effective and accurate search and match process as possible. Another topic that I want to address is performance. Performance has been the steepest learning curve for me working on the Igbo API. It feels like there's so many unknowns and how to test for performance before deploying. It's just a lot of trial and error. But the greatest thing about this approach is that we're not actually experiencing any significant performance issues. That might be due to the fact that we don't have millions of database records just yet, but we're also leveraging Redis to cache our results, and that directly helps with performance, keeping response times lower than 100 milliseconds. But if you feel like you've identified an opportunity for a major performance hit for this project, please let me know in the comment section. The Igbo API has definitely grown a lot since the last time I've spoken about it. I'm actually really excited to see how it continues to improve in performance and value as time goes on. Again, I would love to hear people's opinions or even feedback on how we can improve the Igbo API. If you want to play around with the Igbo API without having to sign up for any developer token or key, you can actually go to our project website here to go play in the demo section. If you're a developer who actually wants to use the Igbo API in their next project, you can create a free developer token at the project website. We also have Nkwa-Okwu, which is our general purpose dictionary web application, where you'll have access to all the data that's available in our Igbo API database. Also, if you would like to directly contribute to the project to add new features, fix a bug, or suggest future plans that we should consider, you can sign up to become a volunteer and work with me directly. You can follow me and Nkwa-Okwu on Twitter if you want to stay up to date with the project, and even get daily Igbo words in your Twitter feed. But with that, thanks for watching, and I will see you all in the next video.